What's going on, everybody? Welcome to the wonder and the mystery of being. This is episode 28, and it's called The Story of Humanity. Now, I know that's a really big, grandiose title, but I feel like this episode deserves it because today we're talking about how we became the creatures that we are, how human beings came to be, at least part of the story. And this part of the story is the story of how we evolved from simpler creatures. And that's a part of the story that I did not grow up believing. And I've come to find very, very compelling. I read a couple of books back to back a couple of years ago, a book called Sapiens, and then this book, The Social Leap, which we'll talk about in this episode, written by Dr. William Von Hippel, who is our guest on the show today. And the reason why I think this conversation is so great is that Dr. Von Hippel is so great at distilling these big gargantuan concepts down to ideas that are really easy to understand. So if you're like me and you came from maybe a more fundamentalist Christian background and maybe a background that, you know, didn't believe in evolution or common descent, sort of rejected the idea that we evolved from simpler creatures, this might be a really revelatory discussion for you. It would have been for me before I knew all of this. And so wherever you're at in your journey, I hope that this conversation is really, really interesting for you. So I don't think I need to do much of an intro beyond that. So without further ado, I hope you enjoy my conversation with Dr. William Von Hippel. I read your book, The Social Leap, on the heels of reading Sapiens. And the 1-2 punch of those two books was so powerful for me. And I loved your approach in The Social Leap about taking a very psychological approach to thinking about evolution. So what I'd love to do today with you is tell the story of humanity briefly.
Sure. Sure.
And your approach is something that it's a unique sort of way of telling that story as far as I've seen. I first found you on Joe Rogan's show. Mm-hmm. So I know you talked about this at length with Joe. His interviews are like 3 hours.
3 hours, yeah.
And I know he kept interrupting your story with like, hey, what do you think? Do you think the monkeys tried DMT? You know?
Yeah, I know. He's semi-crazy, but he's good fun too, right?
Oh, it was great. It was so entertaining. So I don't want to retread that stuff too much, but I would love to just sort of talk for people that are like me, that are coming out of these spaces where we don't know some of these things, just about the story of humanity, because the way that you tell it is so fascinating. So if you wouldn't mind, take us back to, like, let's go back to maybe our common ancestors that we have with apes or something, or maybe we should, how far back where should we start, do you think?
Yeah, so you can start the story anywhere you want. Life on Earth is over 1 billion years old, really, with stromatolites, right? But that took forever to get going because the Earth had very little oxygen in the atmosphere at the time, and literally those early forms of life are a large part of what created the oxygen that enabled later forms of life. And so you've got basically nothing happening forever, and then everything takes off. If I remember right, somewhere around 500 million years ago, I think that's the Cambrian or Precambrian period where you start to get this explosion of life. Now, I'm very much not expert in all those old dates. Yeah. I would not take any of those numbers to the bank with you. But for the story about humanity, what I think is most interesting is the split that we had with our chimpanzee cousins. Mm-hmm. And that's 6 or 7 million years ago. And so in my mind, that's kind of where, you got all sorts of other animals wandering this earth, coming and going and doing all that. But that's where our story, in my mind, really starts. And so if that's a good starting point for you, that's typically where I would begin.
Yeah, that's a really natural starting point for me. I mean, studying common descent, just to touch on that for a second, was super interesting for me, and learning like how much genetic material we share with, say, chimpanzees. It's like something like 96%. Is that
close?
I
think it's actually over 98, but again, that's...
Oh, okay.
I don't remember exactly, so don't trust me. You just Google it and look it up in Wikipedia.
Right, yeah, and Googling it, I sort of found a bunch of different numbers, and I said this in a talk recently that, like, in general, like, with chimpanzees were like 96, 98. Cats were like 90. Cows were like 80. Like bananas were somewhere around
exactly.
50.
Yeah, you know, our cousin the celery uses a lot of the same processes that we use. A lot of the molecules that are mission critical for developing our bodies are mission critical for developing their bodies. The same ones. They do the same things.
It's so wild to think that we have like we share. If you go far back enough, you know, back far enough, we share a genetic history with celery.
Yeah, it's just it's wild, isn't it? And of course, we do with everything on Earth. At least that's to the best of our knowledge. Someday we may discover something that literally evolved completely separately, but that would be unlikely because that would mean that it somehow got started completely independently of everything else that got started. But there's no reason why it can't happen. It just has never been found. Right.
So if we look at like 6.5, 6 million years ago, somewhere around there was an ancestor that we share with other primates.
So basically, I'm sorry?
Oh, I was going to say, do we have a name for that specific ancestor, or is it like a rough grouping?
Yeah, so, well, we have our common ancestor with the other great apes is with the chimpanzee most recently. And so if you go back 6 or 7 million years, we have a common ancestor with the chimpanzee. And then if you go back a little farther, chimpanzees and us, because we were the common ancestor, have a common ancestor with gorillas. And then if you go back even farther, we have common ancestor with orangutans. And then if you go back farther, then we start to blend with the lesser apes like gibbons. And then if you go back farther still, we start to blend with all the monkeys because, of course, the great apes split apart from the monkeys. And then you've got old world monkeys and new world monkeys. So you can keep working your way back until there are no primates at all. But if you look at our common ancestor with chimpanzees, we use the term, I'm not sure if this is helpful at all, but we use the term hominin to refer to once we have this common ancestor with chimpanzee and then we go our own way, all those species that separated from them that eventually led to us, all of them are extinct except us. And so we refer to all of those as hominins. And then we use hominid to refer to the living species of gorilla, chimpanzee, and the extinct ones and us. So we're all hominids, and then we have the smaller category of hominin, which are since our common ancestor with the chimpanzee.
Interesting. Okay, so I didn't realize I've heard both those terms, hominid and hominin, and I never knew the distinction. So now I do. Thank you. So it's almost like different genetic family trees just split off a bunch of times. Is that a good way to think about it?
That's a great way to put it. And so, the one thing to keep in mind is that there'll be splits and then they'll be getting back together. And there's some evidence that happened repeatedly between gorillas and chimpanzees. And there's some evidence that even might have happened between us and gorillas after we separated from chimpanzees.
Oh, wow.
And so, yeah, it's never a perfectly clean, I'll see you, Stan, it's been nice being your buddy, and then we just go our own ways and we never interact again. And that's why the more modern version of that is when our Homo sapiens ancestors left Africa, they encountered our Homo erectus ancestors who had left Africa a million years prior and then had settled in Asia and in Europe, and they then evolved into Neanderthals while we evolved into Homo sapiens. And so we encountered Neanderthals in the Middle East and then working our way toward China and then working our way back to the left toward Europe, and we interbred with them at each of those intervals as well. Now, many of those interbreedings probably led nowhere, but some of them led to those of us who left Africa have and Neanderthal DNA in us. So far, there's no evidence that those of us who didn't leave Africa have any Neanderthal DNA, because to the best of our knowledge, the Neanderthals never went down into Africa because their body really wasn't suited for the heat. And we have no good evidence of early Homo sapiens leaving Africa and coming back. But that may prove not to be true. We may well find, for this ethnic group living in this part of Africa, they must have left and returned, or they must have interbred in some other way, because we do see Neanderthal DNA. Right now, that's so new that we don't know with any certainty.
Right. Well, and that brings up a good point, because we like to think of these things as like clean happenings, right? That like this happened and then this happened and this happened. But as we're studying this stuff that's a long time ago, and it may not turn out to be like a clean through line that we can draw.
Yeah, it never is. It's every time we look at the data. So if you look, for example, at the peopling of the Pacific, as human beings came down across all the Pacific islands, at first we thought it was one event that happened over. It took time to you start up in Formosa, Taiwan now, and you work your way across the Pacific. It's not going to happen overnight. But we thought it was one steady peopling. But then you look at the Y-linked DNA looked different from the mitochondrial DNA. Therefore, there must have been a second peopling. And then you look at the rats that came along on the ship, and their DNA looks a little bit different. And so, then you find, there was some random anthropologist is at a museum in Chile, and they see a skull there that's clearly Polynesian. Well, what's a skull from the 1800s doing in Chile that's Polynesian? And then they go, they must have made it all the way across. And so, it's human nature to see whatever opportunity comes along and to try to exploit it. It's also human nature, this sounds bad, but to kind of have sex with almost anything that's willing, and so they don't even need to be the same species, much less when all Homo sapiens are the same species. And so when humans interact, that's always happening. And so we don't ever find this is this genetically isolated unit, and here's another completely different genetically isolated unit. We find these what we call haplotypes. We find these collections of genes that tend to be much more common over here and much less common over there, but there's almost always some kind of mixture.
Yeah, wow, that's interesting. So let's wind back before that, and let's go back to when, and there's a particular I'm not sure if species is the right word, but that seems to come up in these conversations a lot. It's Australopithecus. Am I saying that correctly?
And that's a genus, and then there's a bunch of different species of Australopithecines.
Gotcha.
Yes,
Afarensis.
right.
I've heard
Yep.
that. So that's the species. See, I'm winding back to my high school or maybe elementary school science. I think maybe there.
Whatever it takes, at least it's still in there.
It's rattling around in there somewhere. Why is it that Australopithecus comes up? Because I don't work in the field like you do, I just noticed that this name comes up a lot in this field of study, and it seems to have some significance that maybe I'm not totally aware of. Why does the name come up so often?
Yeah, that's a great question. And so it comes up often for two reasons. One is it's this sort of intervening link species, and two, it's the first one we ever found that was between chimpanzees and us. And so Ray Dart was actually from he lived here in Brisbane, and he was a UQ. I teach at the University of Queensland. He was a UQ graduate, and he was the one who got his hands on the first Australopithecines fossil and understood what it was. And he realized this is not a chimpanzee; its brain case is bigger. So the average chimpanzee has about 380 cc brain, and an Australopithecus has about a 450 cc brain. So that's an important difference, right? It's already gotten 70 grams smarter.
Yeah.
450 gram brain. And then the second thing about it is that you can tell by the way the head is connected and by other bones in their body that they were bipedal. And so he thought that at the time, and that's proved. We now have lots of good data that that's in fact true. And so you've got this upright walking but very ape-like creature, because our brain is 1350 on average.
Significantly
grams.
Larger.
Yeah, way bigger. So we're like three of them. And so they're basically this enhanced chimpanzee that could walk upright. And it was very clearly this early, people often refer to this missing link. What lies between us and them? And it was the first discovery of what lies between us and them. And since then, of course, we've got many different versions of Australopithecines that have been found, many different species. And we've also got prior species and subsequent species. And what we also have is lots of other species that were happening at the exact same time. And so we think about, you tend to think about your family tree as this very linear progression from one species to another. But in fact, it wasn't a linear progression at all. It was almost like a bushy tree that went out in a whole bunch of different directions that just didn't work out. Now, we don't know why it didn't work out. One possibility is that our ancestors and then us kept exterminating the competition. Mm-hmm. But it could be that it had nothing to do with us, that it was just, they were adapted for local conditions and not as well adapted for changing conditions as we were. And so we don't know with certainty that Australopithecines are our direct ancestors. They could be more like an auntie or an uncle, and that we came down a similar but not identical line. We can't know that because we can't do DNA on material that's old, that's that old, at least not yet.
Right.
Maybe someday we'll find a way, but for now we can't do it. And so what we can do is simply look at the fossil link, and it looks like they were a clear intervening species between our common ancestors with chimpanzees and us.
Right. So that's a great explanation. That really helps me understand. So we're not basing that on genetic information. We're basing that on observing sort of the traits that we see in the, I guess, is it skeletal remains?
Yes.
Yeah.
Exactly right.
And so the way things are connected, the sizes of things, and we can see that it's somewhere in between ape or somewhere in between chimpanzee specifically and human.
Yes.
You think?
Yes, that's right. And so they seem to be quite clearly on a subsequent species from chimpanzees. They're small. They're not like a gorilla. They're not like an orangutan. And so it's highly likely to be derived from chimpanzees, to be evolved from them. And we see them starting a few million years after this split between us and them 6 million years ago.
So that's somewhere around like maybe 4 million.
Yeah, so we see them
like
as
that?
early as 4-ish million years ago, and they were around for a few million years. And so we see them up until 2 point something. I can't tell you exactly, unfortunately, but because there's a lot of them, and I don't do a good enough job of keeping up with exactly when the first one is and the last one. But what we do see is that for a few million years there, and many of them center around 3 million years ago, that they're bipedal, they're walking upright just like we do. They've got a much smaller brain case. And then the beauty is that we've even got some leftover evidence of tools that it looks like they were using. So there are tools from 2 point, we've got even potentially 3.3 million years ago, some possible tools. There's always argument because in order to be certain about how old the tools are, you want a really undisturbed sedimentary layer where you can really easily date every layer. But of course, over time, things get overturned and a river comes through and washes it away, and you don't know with certainty. And so there's some arguable evidence from 3.3 million years ago, and otherwise we go forward to in the 2 million year range, where it could well have been Australopithecines using those tools. Now, we know that chimpanzees use tools. They'll use stones and sticks for tools, but they've never been shown to sharpen stones, like to strike one stone against another. They'll sharpen a stick by biting it into a spear, but they won't sharpen stones, which is a totally different thing. Using one rock against another as a tool.
Right.
I suspect that Australopithecines were doing that, but we don't know that with any certainty.
Yeah, one of the things I noticed in your book is that you made the point that I thought was really interesting about how chimpanzees they'll sort of use a tool that they find at hand, but when they're done with it, they'll just cast it aside and they won't necessarily hold on to it. And that's evidence that they're not thinking about like, hey, I might need this later on. They're not thinking about the future in the way that we modern humans tend to think about the future. Yeah,
exactly. And the same holds for Australopithecines. There's no evidence that they were carrying their tools anywhere, which you would do if you recognize their potential future utility. In fact, my favorite experiment on a chimpanzee's ability to see the future is one that was run here at the University of Queensland by my colleagues John Redshaw and Thomas Sudendorf. And what they did is they presented people with this Y-shaped tube. So it's got one tube at the top that then branches into 2 tubes at the bottom, so like an upside down Y. And they do this with either children or chimpanzees. And they drop through the top of the tube something that you would really like to have. Like for a chimpanzee, it might be a grape. It might be a grape again for a kid as well. And then the chimpanzees, of course, in his cage, because they're not very friendly animals and they'll harm you if they're allowed to get out. But they can reach their hands through and put them underneath this Y-shaped tube. And if they don't, if the grape drops free, it'll roll away from them so they can't get it. And the same for the human. And what you see is, does the animal have the good sense to put out both hands to cover both ends of the tube? And it turns out chimpanzees can never learn to do that. They can't envision mutually contradictory futures. They can make a probabilistic guess, I think it's going to come out of the left. But it never occurs to them, but it might come out of the right, so I better put my hand over the right side as well. And a 2-year-old human makes the exact same mistake. But by the time a human becomes 3 years old, they now can envision, well, it might come out of the left, but alternatively, it might come out of the right. And that seems like a nothing to you, right? Like if you can envision that it might come out the left, it seems obvious that therefore it might come out of the right. But that's actually a mental leap to represent that the future could go 2 different ways and that you have to be prepared for both eventualities. And chimpanzees never got there. And the fact that we did get there is one of the things that makes us such a powerful force on this planet.
That's interesting. I mean, I feel like, for context, I have 2 kids, a 4-year-old and a 2-year-old. So like any of your examples that deal with toddlers, I'm right with you. Like I'm observing that in real time right now.
Yeah, absolutely.
One of the other things that you mentioned about Australopithecus or Australopithecines is I don't say those names with any confidence every time.
No, you got it. You're doing it right.
Australopithecines is plural, right?
Yeah.
Okay.
Yeah.
All right. I'm making progress. One of the things that you mentioned is that they're bipedal, so they're standing upright, and that's different than chimps. And from what I understand, chimps, like they kind of can stand upright and walk, but it's a clunky, clumsy process. And it seems really significant that Australopithecines were upright and bipedal. Could you like expand on the significance of that? Because that seems really important.
Sure. So first of all, the chimps, as you say, they can stand upright, but they can't lock their knees and they can't lock their hips. And so when they walk, it's this very ungainly walk. They prefer to walk on their knuckles, and as a consequence, it's not very fast when they're trying to walk upright, and it's not very efficient. It uses up a lot of calories. I mean, imagine walking around everywhere you went with your knees bent and your hips kind of bent forward. You would be in this very... You'd be. It's like almost going to exercise class and doing. I
literally was about to say that I was in an exercise class like 2 days ago. I'm like, that's exactly what that felt like.
Yeah. And just standing there is effortless. Like we're designed to just be able to stand straight up because our skeleton literally supports itself. And so calorically, if you're going to be on 2 feet, it's a great thing to be able to lock your knees and lock your hips and to walk bipedally like we do. And we know that that Australopithecines could do that from both their skeletal remains and from some very fortuitously discovered footprints in ash that then solidified. And when you model the foot strike of those footprints, you can see that they hit with the force of a heel that would be generated by a straight leg rather than the force of a heel that's generated by a bent leg like a chimpanzee. Wow.
The fact that I didn't realize that that's how one of the, confirming evidences that we've found is that these footprints that are somehow preserved for a few million years. That's wild.
It's the Lamequi. They're Leotoli footprints, and it was discovered, if I remember right, I think it's even like they were just having a picnic there or something, and I think Mary Leakey discovered them. Her family is a big archaeological family, discovered them there, and they dug up the whole area, and it's the most remarkable area where ash had landed from volcanic activity. Some Australopithecines families had walked through it and other animals as well. And you can even see where there's clearly probably an Australopithecine's mother, but maybe a father, picks up the offspring and then puts it down and then picks it up and puts it down, just like we do, right? Because the little prints appear and then they disappear and then they appear and then they disappear. And so it's this amazing lucky find that allows you to see a lot about what was happening in the past, it's not even just mud, it's volcanic ash that then solidified.
Wow, that's so wild.
Yeah, it's very cool.
So, and one of the other things that you touched on in the book is the significance of being able to throw.
That's right.
And that was super fascinating to me.
Yeah. So once you walk upright and you can lock your knees and lock your hips, you start to evolve into a being who has a longer waist and a flatter chest that's more laterally oriented to the world. So if you think about our chimpanzee cousins, all their muscles aim mostly up and down because they're going up and down trees all the time. And so they want to be able to pull things really well up and down. And of course, they're stunningly effective tree climbers as a consequence. But they're not so good on the ground because their musculature is not very laterally oriented, so they can't deal on the ground with things as well as we can. So once you get to Australopithecines, and now they're walking upright, they've got this longer waist, it allows their body to rotate in a way that a chimpanzee's body can't rotate. And so if you watch a chimpanzee throw, even though they're pound for pound way stronger than we are. They throw very poorly, low accuracy, not very strong, and they typically will throw with two hands overhead like that. They're throwing with one arm. They can do it, but they're horribly inaccurate and not very. They don't generate anywhere near the power that we do. And so what happened is that once we started to walk bipedally, we could generate this elastic energy that comes across your body. So if you look at a really good thrower, like a baseball pitcher, they step forward with the opposite leg and they cock their arm back, and then the whole body kind of stretches. In the very last minute, they release with a snap of the wrist. And when you model the energy of that, the biomechanical energy, what you see is that what happens when the pitcher throws is all the muscles, tendons, and ligaments stretch to their maximum stretchiness, and then it's like the snapping of a rubber band when the ball is released. And so it's that capacity to spin your waist and to spin your shoulders and to have a flexible enough wrist and elbow to be able to do that, which a chimpanzee has none of that. And so what almost assuredly happened is with the advent of Australopithecines who have all that, not fully in place, it's not really fully in place till we get to Homo erectus, who's 2 million years ago, but they now have the capacity to kill at a distance by throwing. And killing at a distance is the single most important invention in military history because it allows a larger force of weaker individuals to kill a smaller force of stronger individuals. And the example is, of course, like imagine that you want to kill a lion and all you can do is club it to death with a rock. Well, who's going to go first? Because whoever goes up to start clubbing the guy first, is going to get eaten, right?
Yeah.
Whereas if you could throw stones at it from a position of relative safety, you could either drive it away or even kill it if it refused to yield, because there'd be so many rocks coming at it from so many angles. And chimpanzees can't really do that, and Australopithecines now have the body where they could do that.
Wow. Yeah, that was one of the points in your book that like really kind of blew my mind, because it does make complete sense once you think about it. It's like, because I can't think of examples in the animal world, outside of human beings or where that really happens, right?
Right. Well, some animals can kill over very small distances. So they'll, like an iguana or something, can shoot its tongue out and get a insect. But it's a moment away. Or some animals will shoot poison, like the bombardier beetle protects itself by shooting poison out of its bum. But it has a very limited range, right? You can do that over when you're really being threatened right now, or when you're about to grab your prey. But a human being can throw a rock, 20 meters with ease. And no other animal has they can't do anything to you when you're 20 meters away. And so suddenly you've opened up a way of defending yourself and attacking others that's available to no other animal on this planet.
Yeah. And I mean, you sort of see, again, coming back to my kids, like they love throwing stuff.
Yeah.
They start throwing stuff very instinctually, it seems like.
Yeah. They do. And the thing is that it's like, we tend to think about evolution, about these physical changes between chimpanzees and us. We were just talking about a bunch of them as we became bipedal. But there's psychological changes too. So if you've evolved an animal that now could benefit by throwing, well, then those animals that happen to enjoy throwing and therefore practice all the time are going to be more effective than those animals who don't enjoy it. So if you happen to have two children and one loves to throw and one doesn't, and you're an Australopithecus, well, the one who loves to throw will throw all the time, and then when the time comes, he's going to throw accurately and kill the beast that he's trying to kill and survive. And the one who doesn't like to throw will be now throwing for the first time and won't be very good and will get eaten. And so to the degree that attitude is heritable, the desire to throw a rock is heritable, then whoever has that desire is going to pass on, have more kids who share that desire. And so our attitudes have to go along with our body. They have to match. And so if you're a human being that loves to eat feces, that's a really poor attitude for a human, because our gut is not designed to process all the bacteria that's in feces. But if you're a dung beetle who finds feces distasteful, well, you're in deep trouble, right? Because that's all dung beetles eat for a living, and now you've got a real problem. And so when we think about evolution, we think about the physical side, but the mental side is just as important.
Yes.
And it turns out that most attitudes are heritable. And so a loving of throwing is something that should be pretty much species-wide. By and large, little kids ought to love to throw, because that'll be something that helps them develop that skill, and then it probably played a really important role for our ancestors in their survival.
Well, and that touches on two things that I think are really important. I mean, first is, and I'd love to talk to you about this more, is the sort of social and psychological aspect of evolution that you're entirely right. Usually when I'm exposed to conversations about evolution, it's generally about physical traits. But the other thing that's worth noting is that like these changes happened over very long periods of time.
Yes.
And in recorded history, like our sort of recorded history that we have some understanding of only goes back a few thousand years, really.
That's right.
And so in that period of time, like there hasn't really been significant evolutionary changes to us as human beings in a couple thousand years. Is that right? Or
yes,
or am I wrong on that?
So no. So there are. So the best way to look at that question is to look at what we call sweeps. And a sweep is when there's some new random mutation that turns out to be so useful that it sweeps through the species, like everybody ends up having it.
Oh.
And so there's a paper that came out, I don't know, maybe 10 years ago now, where they modeled all the sweeps. And you can do the quantitative genetics to look at the age of a sweep. And the way you do that is you look at how much genetic material is on either side of the key gene. And if it's a relatively recent sweep, all the random stuff that happened to be around it will still be attached to it because it hasn't been sort of pared away over time because it's irrelevant. Oh. But if it's a really old sweep, it'll just be that one key gene basically because all that other random stuff that sits around it has long since been pared away in other random sexual reproduction processes. You know, in meiosis, it's a long, complicated biological story, but
sure.
But the genes shuffle around, and so that shuffling process will get rid of the chaff and just keep the wheat. And so when you do that, you can actually see that the speed of evolution accelerated over the last 10,000 years.
Really?
And in all probability, the reason it accelerated was the advent of agriculture, which led to new evolutionary pressures on us, as we now have totally new diet, very starchy, and not so much meat and nuts and things like that anymore. And then secondarily, you have so many more humans. The carrying capacity of the land goes way up when you have agriculture. And as a consequence of that, if you think about a mutation, it's sort of like you bring me your new Ferrari and I'm your mechanic and I say, I got an idea. Let me throw this wrench into the middle of the engine. And you're like, are you kidding me? That's not going to help. And of course, 99.999 times out of 100, all I did was bang up your Ferrari when I threw my wrench at it. But maybe that one time, 1 out of 10,000 times I threw the wrench, it just adjusted the carburetor ever so slightly to be at a better angle. And now the car's a little bit faster. And that's what mutations are. So when you don't have very many humans, because almost all of them are either neutral, they just dented the exterior and didn't make a difference, or bad, they actually caused it harm by disconnecting the carburetor, then the mutations tend not to sweep. But if you've got enough humans, then a good one has a better chance of coming along and then it can sweep through the population. And an example of a very recent sweep that hasn't even completed itself is lactose tolerance.
Oh!
So if you look at your ability to process milk as an adult, no, humans couldn't do that. I'm going to make up the number, but I'll call it 10,000 years ago. Nobody had that gene. And the reason for that is that it's expensive to continue to produce the lactase enzyme as an adult when you never drink milk. And so why would your body keep producing an enzyme that's effortful to make and does you no good because you're never drinking milk? And then some humans started to keep goats or cows or sheep. And as a consequence of keeping them, some of them decided to drink the milk and not just let the babies have it. And that was a great source of protein, and it gave them a terrible stomach ache because they didn't have lactase enzyme anymore. And then some of them luckily still had it, and now they were the only ones in their group that could drink all the milk and get all that extra protein, and now they're big and strong, and they have lots of babies, and they survive really well, and that gene just sweeps through the population. But it wasn't long enough ago to sweep through all humans on Earth. And so lots of humans are lactose tolerant, and lots of humans aren't.
Wow. I have never heard that before. That's incredible. Like, I see what's interesting about that to me is that like, I remember when I was a kid, if like I had a friend that was lactose intolerant, like another kid that was lactose intolerant, I sort of categorized that mentally as like, oh, he has like a deficiency or a disability. It's not like a disability, but it's like,
right.
You know, it's like, oh, we're normal over here and he's got a weird thing. But it sounds like in a sense, it's almost the opposite. Like, it's like well, maybe not the opposite, but we evolved to have this ability more recently.
Yeah, we happen to have it sweep through our subset of the population because it's enormously helpful, but it wasn't long enough ago that it covered all humans on the planet, and not all the human groups who had it interacted with each other. Now, it was so helpful to those humans who had it that it probably helped them get bigger and stronger and conquer other humans and take them over and then interbreed with them. And, so it would have spread most places on the globe, but not everywhere, not to every human. And of course, the gene that allows for it is probably, I don't even know the genetics, it's probably dominant, but I don't even know that for a fact. And so it may be that you need to have both, from both your mom and your dad to have it. I've never looked into it, but it's a good example of a relatively recent sweep. Now, of course, there's no longer any evolutionary pressure on the lactose gene, the lactase gene. And so when I go, the coffee here in Australia is really wonderful. And
yes,
so when I go to the barista, when I go to my favorite barista, I just say, oh, could I have that on lactose-free milk? And there's no harm to Bill that he can't process lactose very well. It gives him a tummy ache because the world has changed in a way that now that deficiency doesn't cause me a problem. But what it does highlight is all the human variability that we have on this planet. And what we tend to get is that the humans tend to adapt their bodies to the local ecology in some smallish ways, and then culturally they adapt their mind to the local ecology in very large ways. So humans have the advantage that because we evolved to use culture, we don't need to change our bodies in order to fit the environment. And imagine that no one had ever evolved the lactase gene, and so that wasn't a solution. Probably people would have found a way to cook the milk or mix it with something else to cause the lactose to be neutralized, and then we could drink it anyway, because we do that all over the world. We find foods that are largely inedible, and then we find ways to make them edible. And in this particular case, it happened genetically, and so it created that human variability, but it didn't need to.
That's so interesting. Yeah, because so many of the foods that we eat and that we're used to eating we wouldn't be able to metabolize them or digest them properly if we hadn't learned to cook or somewhere.
Exactly. Cooking is a perfect example. And then there's also local ways to cook certain local foods and to only harvest them at a certain time of year. And, we learn that everywhere we go.
Yeah.
And the best example of how important that learning is that when you look at European explorers, here in Australia or in Asia or in North America when they first arrived, they often starved to death where a local 12-year-old would have had plenty to eat. Now, how could this well-provisioned European explorer with all the fancy equipment starve to death while the local 12-year-old who has none of that equipment is just fine? It's because he doesn't have that local 12-year-old's knowledge about which plants are edible and how to make them edible and what time of year to eat them, etc.
That's so interesting. Okay, well, I'm learning here. So, but let's. I felt I may have taken us down a sidetrack with the sweeps, but I'm really glad that I did, because I had never heard that.
Okay.
So let's go back to sort of obviously, like the social and psychological aspect of studying this journey. Obviously, like chimpanzees, gorillas, they are social creatures. They live in groups. We see this in lots of mammals, or not just mammals, but we see this in a lot of animals.
That's right.
So how do you feel like the social and psychological aspects of our journey sort of played out, coming from chimpanzees to Australopithecus and into the humans that we are today?
Okay, so that's a great question. Now, as you point out, we know lots of animals are very social and they cooperate with each other very well. Ants and bees are the prototypic example where they cooperate incredibly well. But we also have like hunting dogs, which are very cooperative with each other. We've got orcas, which are killer whales, which are very cooperative with each other. It just so happens that in our line, chimpanzees are not very cooperative with each other. They will cooperate under some circumstances, but they're far more competitive with each other than they are cooperative with each other. And there's many examples of that. I guess my favorite example is there's an experiment where what they do is they bring chimpanzees into the lab and they put this tray on the ground and they run 2 ropes through the tray, and the tray sits on wheels. But because there's one rope, but comes out both sides.
Right.
And now the problem is that there's no knot in the rope. So if you only pull on one side, you'll just pull the rope through and it won't move the tray. But if you pull on both ropes, now the tray will roll in toward you. And so what they do is they design it in 2 elaborate ways. The ropes always end too far apart to reach both ends. So it needs 2 chimpanzees to pull at the same time. And then the way the tray works is you can either pull it. So let's say you and I are doing this game. We can pull it if we both pull on the rope at the same time, my tray will come to me and your tray will come to you. And let's say there's bananas on it. Well, we love bananas. And so I yell at you or I wave at you or whatever. And you say, yep, I'm good. And so we both grab the rope and we pull and we get our bananas. And we can do that till the cows come home. We'll cooperate with each other forever. But if you redesign the experiment, so now that when we pull on the rope, the tray only goes to one animal, so the other one doesn't get it and has to go around. Well, if you do that with humans, they'll pull till the cows come home too. I'll make you a deal. I say, hey man, I pull, you pull, come over, we'll share the bananas. And you're like, I'm with you, Bill. But a chimpanzee, once that happens, the two chimps pull on the rope, and then the dominant chimp eats all the bananas and won't share it all with the other chimp. Well, what's the consequence of that decision? The other chimp stops pulling on the rope. It's like, well, I'm not going to cooperate with you if you're not going to let me share, right? But it can't get it. It can never learn. Even though I might want to eat all the bananas, I got to at least give you some in order to get you to play this game. They're completely incapable of learning that. And there's in the wild and in the laboratory, we see that same story over and over again, that their fundamental orientation toward each other is competitive and driven by hierarchy rather than cooperative and driven by a desire to achieve a group goal. So how do we get from there to here? Now, if they were hunting dogs with their brains, they would be very different, or orcas or whatever, but they're not. That's where we came from. And so what we don't know with any certainty, but what I believe happened is that once Australopithecines gained the capacity to kill at a distance by throwing, now they've suddenly got this enormous evolutionary pressure on them to cooperate. And the reason for that is, prior to the capacity to throw, if we're all Australopithecines walking across the savannah together and along comes a leopard or a lion or even a saber-toothed tiger, because they lived it there at that time, we would go, holy cow, and we'd just sprint for the trees, because that was the only chance we had of survival, because we can climb better than they can. And whoever's the slowest, that we're, as Australopithecines, we're way slower than those big cats. Someone's going to get eaten, and I just hope, nothing personal, but it's you and not me. And so so our orientation, it make perfect sense to be just looking out for number one. But now, once we gain the capacity to throw, well, it doesn't do me any good to throw rocks at a lion. I'm going to end up in the stomach of a slightly bruised lion. The only way that's of any beneficial to me is if you throw rocks at the same time, and so does every other Australopithecine in our group. And so if all of the Australopithecines gather together and they all throw rocks at the same time, because we're all together anyway, we're kind of crossing and we're nervous and we're looking around. If we all decide to cooperate and throw rocks, we could drive that beast away, and it'll actually make all of us safer. But if half of us throw rocks and half of us run for the trees, well, we're probably still stuffed. And so I would imagine it took thousands or maybe even millions of encounters where they could have thrown rocks but didn't occur to them. And then one day the penny must have dropped, and it happened to be a group where every Australopithecus in the group happened to be really cooperative, and they all did it. And they're like, holy cow, how good was that? We drove that leopard away, and none of us died, because now it's, we may have only had a 1 in 30 chance of dying before, but now none of us are dead. And so suddenly, for the first time in our line, this primate line, or this great ape line, because there are some other cooperative primates, but anyway, for the first time in our immediate line, we now have the case where the group interests and the individual interests are perfectly aligned. And now we all want to cooperate with each other because it'll benefit all of us. And of course, then it makes the group much more powerful than just a collection of individuals, which is all it had ever been when we were chimpanzees. Yeah. And now going forward, that changes everything. Because now if we can cooperate and work together, well, if we get smarter, we could do it even a better job. We could start planning for the future. We could have division of labor. We could have all sorts of things that we know first emerged in our line about 2 million years ago with the advent of Homo erectus. Right. And so for the first time in our line, that social compact that we made with each other to cooperate with each other, it actually changed our own evolutionary trajectory, and it made brains much more valuable for us. And it also enabled us to pay the cost on the brain by becoming more effective hunters, and therefore bringing in more calories in order to support this really expensive tissue that we have in our head.
Yeah, that's great outline. And one of the things that always jumps out to me when I'm thinking about this stuff is like, it wasn't necessary for these creatures to understand, like they don't have to understand these processes. They just have to behave as if they do. Like
exactly.
So
and none of our, this happens over and over again. So if you look at the desire to have babies, we didn't evolve a desire to have babies. And our ancestors didn't understand that when they had sex, they had babies. All you have to do is give the animal a desire to have sex, and then give it, if you're mammals, and so you have to care for the baby, give it a tendency to be nurturant to whatever baby comes along. And so the lack of understanding is completely irrelevant. You motivate, the motivation to have sex is one of the strongest motivations in any animal. Tons of animals die in order to have sex. I mean, look at spiders. The female often consumes the male during sex or immediately after sex. Many animals, that's the last thing they do, but they do it anyway because the desire to do it is so strong. They have no understanding, if I do this, I'm going to die, but I'll have babies, and how should I weigh that out? None of that has to happen. They just have to be motivated to do it. And so in this case, those ones who are motivated, I'm scared, let me throw rocks, let me try to drive that away, and they all did it at the same time. And then they look at each other, wow, that worked like a dream, right?
Yeah.
And then hopefully they repeat that action.
Yeah. So we start to see with Homo erectus is where we start to see things like division of labor and
That's right.
Evidence of things like that. And that's critical because then people can specialize, right?
That's right.
Or
and
individuals can specialize.
Even if you don't specialize over the long term, you can specialize in the short term. And I can say to you, okay, so let's take, for example, when monkeys hunt, or when chimpanzees hunt monkeys. So they often do. Colobus monkeys are a good example. They're kind of slow leaf-eating monkeys, and they don't get as much energy from the leaves. And so chimpanzees can catch them and kill them and eat them. And when a bunch of them band together to catch these monkeys, they do better than when they're by themselves, but they only do better in this additive fashion. Two of them get as many more than one as you'd expect. If their probability is 10%, then it goes up to 20%.
Sure.
They don't gain anything beyond just adding them together. In contrast, if you look at human groups, I would say to you, okay, here's the plan. I'm going to come running at these monkeys from this side. You wait over there, and when they run away from me, you grab them, and then we're golden and we'll share them. And you're like, Bill, I'm with you, right? And so how do we see evidence that an animal can do that? Well, we can look at chimps and we can see they can't, because they just do it in this random crazy process, and they end up with as many monkeys as you'd expect by how many are trying.
Sure.
But if you look back at Homo erectus, you see a few things. First of all, you see them eating and butchering huge animals like elephants, and eating and butchering fast animals like horses. And It's hard to imagine humans catching an animal that fast or an animal that big without planfulness. But it's also the case that you see some really cool evidence that they must have worked together and they must have had division of labor. And my favorite example of that is there's a site in India that's 1.2 million years old where they were making stone tools. And they have these they're called Acheulean hand axes. And they're very hard to make. They're these bifacial symmetric tool that you can use to cut through hides and break bone and stuff like that. And they're a super common tool among Homo erectus. And what we can see is it's a multi-step process. The first thing you have to do is knock loose a big stone, and then you have to knock big pieces off it, and then you do the finer edging at the very end. And what we see at this site in India is that the big pieces were knocked off here, and then 20 meters over to the right, we see somebody knocking the medium-sized pieces off, and then 20 meters over to again, we see somebody sharpening it by looking at the sort of shrapnel that's left on the ground. Well, why, if you're doing this by yourself and I'm doing it by myself because we're two Homo erectus buddies, why would we break it loose in one place and then walk 20 meters and then keep working on it? We wouldn't. We'd break it loose, sit down, and work on it. But the fact that there are these sites suggests that I'm the big guy in the group. I go bam and I knock it loose, and then I hand it to you because you're really good at the next phase of breaking them loose. And you take it over there and you sit down at your stage and you work while I bang and knock some more loose. And so the fact that we see this kind of spatial differentiation in the site is pretty darn good evidence that they're actually working together in a division of labor kind of way.
Yeah, and they wouldn't just like, I'm going to do this thing and then move over 10 meters and then do this thing and then move over 10 meters. Like, They wouldn't do that.
And even if they did, they would never do it systematically. They wouldn't have, here's where I knock it loose,
Right.
Here's where I work on it next, here's where I work on it. They would just randomly, because maybe their butt is sore and they want to move. So that's one side of the coin. The other side is what we also see with Homo erectus for the first time is that these tools that they then made are carried great distances with them. And that allows that makes you realize, they could envision that they'll need it again in the future after they've used it today. And so that's a critical capacity for this division of labor as well, because I have to be able to think, well, what do I want to do? And what would I like John to do? And how might we work best together? That same future planning capacity is involved in the division of labor. So it's sort of no surprise that those two things get packaged together for the first time in Homo erectus.
Interesting. So is I also, like, in your book, one of the other things I really hadn't never considered before was, once we get to, I mean, you feel free to correct me on exactly when this maybe started to be a factor, but once we get into these really highly socialized sort of situations where there's division of labor and there's evidence of them thinking about the future and planning for the future, working together on big hunts and things like that, you start to get into these situations where we have to learn how to work together. And so we have these factors, things like how do we know when people are telling the truth, or the role of gossip, and I know you mentioned theory of mind in your book, which I have a 4-year-old, so I'm seeing that now.
Yes. Yeah, exactly.
Theory of mind, for those that are watching and listening, theory of mind just is the idea that you discover that what's in your mind is maybe not in the mind of other people in your group, and they might know things that you don't know, and vice versa. That's basic theory of mind. But maybe you could talk about gossip and lying and how we understand each other.
Sure. So now, keeping in mind that we don't know exactly when these things happened, because again, we don't have good genetic data. We know, for example, what the genes are that are involved in my ability to speak, but we can't do the genetics on a 1,000,000-year-old fossil and see if it could speak, or if at least it had the genetic architecture that would allow it. But if you ask yourself, well, when would there start to be this evolutionary pressure on us to speak? If you accept that in all probability, it started out gesturally, because chimpanzees even can gesture, and they'll make noises randomly and gesture, and they can understand each other that way. And when human beings speak, we move our hands, which suggests that it's an old habit that we had that probably helped us communicate a long time ago. Exactly. And so when would we shift from gesturing to really wanting to be able to do something much more complicated like speak, which allows you to communicate much more? And what I suspect is people argue about when it happened. Some people think it began maybe 3 million years ago or 2.5 million years ago with the advent of tools, so you can explain to somebody else how to make the tool. I don't think so. And the reason I don't think so is because they couldn't envision the future then. They never carried those tools that they were making. Those are called Oldowan tools, and there's no sign that they were ever carried any great distances, so probably they couldn't envision the future, and so probably they didn't have theory of mind, so probably they didn't think they needed to teach you. They didn't understand. If they know how to do it, they wouldn't understand that you don't. But once we get to Homo erectus now, who has all that in place, well, now we're talking about the future. So you and I are both Homo erectuses, and we're trying to plan a hunt. I see some elephants down in the valley. I want to scare them and try to get them to fall off that cliff, or I want you to roll that big rock on them. Well, now I'm trying to get to talk to you about the future, and pointing and gesturing doesn't work so well anymore, because you're like, well, when am I meant to do this? I don't see a rock. I don't see it, And so once you start to have in mind events that are neither here in our immediate locale nor now in our immediate time frame, gestures don't work so well anymore. So they work great when you and I are sneaking up on the bad guys, and I point that way and for me, and then I point that way for you, and we surround them, right? That's great. But if the bad guys are tomorrow, how do I communicate that to you? And the only way we can do that is with language, where I can say, hey man, tomorrow, here's what's going to happen. And so my bet is that we shifted, I don't know, total guess, that we shifted from gestural communication to starting to have actual speech to represent complex ideas once we could envision those complex ideas, which are about tomorrow and about somewhere else. And that would have happened with Homo erectus.
Wow.
And so we know that the first evidence of Homo erectus is 2 million years ago. So somewhere between 2 million years ago and when our species came around, and we don't even know with certainty that the very first members of our species had language. It doesn't fossilize. So, but somewhere along the way, they would have then started to speak. And then once they got that, now it opens up an enormous world of possibilities to you, because I can communicate incredibly complex ideas to you. And perhaps most importantly of all, we can now leverage our sociality in a way that no other animal can. And so if you just think about this example. So imagine you arrived on my campus, you've never been here before, and you're late for a really important meeting. Maybe you've got a job interview and you can't find the building. And you can say to me, hey, Bill, where is building X? And it'll take me 1 second to transfer 12 seconds to transfer the knowledge in my head to you, because I can talk to you.
Yeah.
But if I were another animal, I would say, oh, if I want to help you, let me walk you across campus. And so now it would still be a benefit, because it would take 5 minutes of my time. It would save you hours of your time because you're lost, and then you would get the job because you didn't arrive late. So the animal will still do it, and we have lots and lots of examples of that. But only humans can because we're basically information machines. Only humans can help each other where the benefit is so enormous and the cost is so low. Where I can quickly transmit super complicated information to you. And that's where gossip and storytelling and all this stuff comes from, because now I can tell you, you guys would not believe what happened to me yesterday. I'm out hunting and I get attacked by a lion and I think I'm a dead guy because it's so much bigger than I am. But as luck would have it, there was a fire right next to me and I grabbed a branch from it and the lion was scared and it ran away. And you're like, holy cow, I didn't know lions were afraid of fire. That's super handy to know. Next time I'm anywhere near a lion, I'll make sure that I've got a burning branch, right?
Well, and then like one person discovers something important and that information can spread really rapidly when that would be much more difficult.
Exactly. It can spread rapidly and it can spread permanently. And so every other animal, their culture doesn't evolve and doesn't ratchet up and become more complicated and doesn't become richer. It basically stays where it is. There's little tiny bits where they can learn and then they can pass that on to their offspring. And there's some really lovely examples of that, but they're really small things that they've learned, like dolphins learning to put a sponge on their nose so when they nose around in the dirt to find food, they don't scratch their beak. And the mothers teach their daughters how to use a sponge. They dig one up. Sponges grow into the sea. They grab one and then they go around with that. So that you can get that kind of cultural transformation among some animals, monkeys as well, but basically, and some birds. But basically, human beings can go from knowing nothing to knowing an incredibly complicated array of information because we can communicate so much better than any other animal with so much complicated information that we're passing on to somebody else.
Wow. Okay. That's really interesting to think about. Cause then, my 4-year-old has more knowledge about the world than most animals, or I guess
most animals. And even your 4-year-old probably knows more about the scientific world than anyone on the planet did 20,000 years ago. Because your 4-year-old probably already knows that the Earth rotates around the sun. There wasn't a human being on the planet who knew that up until Copernicus, right?
Well, there's still some that deny it. So
of course, there's a few, right? But and Copernicus is only hundreds of years ago. But
right.
if you look at the science that a 4-year-old knows today, it'll outstrip anyone who lived on this planet pre-agriculture.
Yeah. Well, what that's really interesting, what that shows me is that like the way I'm thinking about that as you were describing it is that like it seems like for most animals, like they're born with certain instincts that have had evolutionary benefits, so they were carried along the line. And so those are sort of behaviors that are just sort of instinctual. And then they can learn things along the way, but very little of what they learn gets transferred to their children, enough that we could call it culture.
Yeah, so so people argue that animals have culture, but it's much simpler than ours. And the key difference is that, so like, let's say that I'm a puma living in Patagonia, and I want to teach my young to hunt because, they raise their young until they're quite old. They put a lot of effort in them. It's not like a lizard, which will typically lay an egg and goodbye. The animal has to figure itself out. So there's a lot of teaching there, but it's like, I'll show my baby puma. We don't quite know how they communicate. It's presumably just by watching, but what we do know is the mother will repeatedly hunt these sort of alpaca-like beings there by coming at them from low ground onto high ground because they're just too fast. If the alpaca's running down a hill, you'll never catch it. But if you get below them and all they can do is run uphill, you've got a decent shot at catching it. And we know that the baby pumas seem to learn this, but they don't ever move beyond that one lesson, right? Because they can't sit around the fire and say, well, here's the 27 things that are going to make you a success in this environment. Rather, they've got one strategy that works particularly well there, and they can teach their child that one strategy, but they don't even understand what their offspring does and doesn't know because they don't have a theory of mind. And so all they're doing is instinctively, when the offspring gets a little bigger, letting it come and watch a hunt. And then by letting it watch the hunt, it goes, oh, I'll run from below and I'll catch it, and I watch my mom succeed that way and fail that way. Whereas we know when we take the kid out, all right, you don't know, you'll cross the street when cars are coming. So that's a rule I got to teach you day one, right?
Immediately.
We know what they know and what they don't know. And as a consequence, we not only other animals can teach, but we can teach by taking advantage of what our grandparents learned. And they took advantage of what their grandparents learned. And so the cumulative knowledge that sits in me is both extraordinary in the sense that it's built up of generations of humans, and it's very specialized. I have no idea how the microphone and computer work and the internet and any of that stuff that sits between you and me, but somebody else does, and I just rely on them to make sure that you and I can talk to each other from thousands of miles apart.
Yeah, that's
and for animals,
division of labor on steroids. Yeah,
exactly. And for and division of knowledge. I say to you, well, look, I don't need to know this because somebody else does. And for animals, they have to, all that knowledge has to be packed in every individual head and has to be taught individually to them by their mother, and without any words and without any knowledge of what the animal knows and doesn't know. And as soon as you do all that, you go, wow, that might be a form of culture, but it's going to be really, really thin and impoverished. It's nothing like what we've got.
Interesting. So it seems like from a psychological point of view, there's sort of like a point at which our ancestors hit some sort of critical mass. Maybe it's not accurate to call it a single point, but a range maybe of like, you get to a certain point where our ancestors had enough abilities that they could begin to accumulate. You used the word cumulative, and I think that that's really a helpful way to think about it. So we're all of a sudden able to accumulate knowledge and transfer it through the generations, and that seems to start a process that rapidly accelerates our understanding of the world, our culture. Is that a pretty good way to think about it?
That's exactly right. And the beauty is that we're so social that we engage in these processes that we've evolved to do that make perfect sense for an animal like ourselves, but that wouldn't make sense for other animals. And so one of my favorite examples is what's called over-imitation. And so Andy Whiten is the one who started this work. And what he did is he creates this complicated treasure box, which has all these bells and whistles on it and latches and hard to figure out how to open. And he shows either a chimpanzee or a child how to open it. But when he starts showing them, he does some irrelevant things like tapping on the top, which actually does nothing. And then he does the key movement and it pops open and there's something tasty inside. And then he gives it to the chimp or the kid and they do exactly what he does. So both chimps and kids understand, I don't know how to open that box. That guy does. He showed me how. I'm going to do what he did. But now what Whiten does is he takes the same box, but now it's completely transparent. It's made out of plexiglass, so you can see through it. And now when he taps on the top, you can see that does nothing. There's no movable parts up there. It's the poke at the bottom that he did that actually caused the box to open. And so then he hands it to a chimp, and it skips the tappy tap, and it just pokes at the bottom and gets the treasure. But he hands it to the kid, and the kid still goes tappity tap tap on the top before he pokes it at the bottom. Now that seems stupid. Why would the kid emulate actions that or imitate actions that are completely meaningless? Well, it makes sense if you think about the fact that the kid has theory of mind. And he says, well, I don't know why that guy tapped the top first, but he understands the subject and I don't. And maybe there's a hidden meaning to tapping on it that I ought to follow. And that hidden meaning probably allows lots of populations around the world to detoxify foods, for example, that they don't even understand why they're doing what they're doing.
Right.
They go through this elaborate 27-step process without knowing what it means, but that's what they were shown to do because that's what worked in the past. Now, the key thing to keep in mind about this tendency is that it allows us to develop cumulative culture because we just faithfully replicate what we've been shown, even if we don't fully understand it, because we assume that there's meaning behind it, but it also creates ritual. So if I go tappity tap tap on the top and it really is meaningless, well, you're going to go tappity tap tap on the top too. And it's this ritual opaque action where you could imagine, we don't know, but you could imagine that religions began this way. That I did some opaque action that you don't know why I did. And you say, well, I have no idea why Bill did that. Maybe it's to satisfy beings that I can't see. Maybe it's to satisfy powerful spirits or entities. And so our tendency to over-imitate makes us really effective in different environments because we make sure that we gain our ancestors' hard-won experience, even if we don't understand it. But it also introduces a little bit of noise into the system by getting us to be very faithfully enacting rituals that we don't understand that may be completely meaningless.
Interesting. Yeah, I hoped we would get here. And so that's really interesting. One of the other things I wanted to ask about is I hadn't really picked up on previously. If you mentioned it in your book, I must have missed it somehow. But connecting speech with the discovery of the future, that seems really interesting and related to what you just mentioned. Because when I think about the discovery of the future, like, if a creature begins to understand tomorrow or next week or next year, and then begins to notice, hey, all these other, whether it was, Homo erectus or whatever, all these other people, as they get older, eventually they all die. And that means that I will probably die too at some point. Like at some point we discovered our own mortality.
That's right. And you're exactly right. And so Thomas Suddendorf talks about this capacity to see into the future and to see multiple possible futures as both a huge blessing, right? Because it allows you to decide what you'll do. You could practice something in order to shape your own future. I want to be a baseball player. I better practice baseball a lot. I want to be a piano player. I better practice, because you don't just start out life knowing how to do those things. So you can shape your own future. You can simulate the future in order to engage in complex plans and then say, oh, wait, that's not going to work if I do it that way. I'm going to get beaten up. I'll try it this way. And then that avoids getting beaten up. So it's super important. But it also introduces a lot of anxiety into your world.
Yes.
Because your dog doesn't worry about tomorrow. It doesn't have any concerns because it can't envision tomorrow. But you can. And then you start to realize things like, holy cow, everybody dies. That's going to happen to me too. And then death turns out to be super complicated because, so you and I are friends our whole lives. We've always hunted together. You've been my mate who I can always count on, and vice versa. And it's because of each other that we survived. And now we're out on a hunt and you get gored to death and now you're dead. Well, A, you're no longer of any value to me, even though the memory of you is super important. But B, you're actually a threat to me now, because as your body starts to decompose, all sorts of nasty creatures are going to dwell in you that could make me sick and could kill me. And so that point of death is not only like, uh-oh, I've lost John, and he was my key hunting partner my whole life, and he was what helped me survive. But it's also, uh-oh, I don't necessarily need to know this cognitively, but everybody in my group, whoever hangs around, who takes the dead person with them and brings them home and brings them back to their dinner table, they end up dead too, or sick. And so John has suddenly got new characteristics about him that I have to be very careful about. And so a lot of magic. So, until very recently, human beings didn't understand germs.
Yeah.
Because, they're so small, you can't see them. How could it possibly be something that small could kill me? Well, it's because we didn't understand this exponential process when they reproduce inside us and then can do us so much damage. And the way we evolved a way of dealing with that before we could understand it was by these magical properties of transmission. And so if you're infected with something, there's some magical way that if I touch you or get close to you, I could become infected with it too, magically. But of course, it's not magic at all. It's very scientific, but nobody knew the science.
My brain goes to like leprosy, for instance.
Exactly.
Like leprosy, leper colonies, where like we got to separate ourselves from those people because there's something about them that's unclean.
And that could make us sick. And every single dead body holds that threat. Now, maybe if you're an Inuit living up in the Arctic and it just freezes solid, there's no threat at all till summer. So you could bring the body home with you and put it in your igloo and you could keep it for months without any risk whatsoever because it's just frozen solid. But most humans wouldn't have been in that situation. And so most humans have this weird situation where you were my best friend, or my wife, or whatever you were, doesn't matter. You were a big plus to me, and now you're not a plus at all, and you're also a potential threat to me if I keep you around, so I need to do something with you. And then every society develops these funeral rituals of what it is that I do with you. And they could be we burn you, and it could be that we bury you, but either way, we're getting rid of you, and then we still remember you, and I think, well, what would John do in this situation? Oh yeah, he was really good with saber-tooths. I'll do that too. So it's this very interesting combination of ritual where we over-imitate, and now we understand death, and it's a scary thing. We don't quite know what it means, and then we also know that the body's not the same anymore. Once John's dead, his body doesn't do anything other than potentially make me sick.
Wow. Yeah. And so, I mean, you could see with all of those factors in play that you would begin to tell stories about what's going on there. And yeah, go ahead.
And they always do. Every society we've ever encountered has some form of religion. Now, their religions tend to work very differently from the religions that we're familiar with, the Judeo-Christian religions, where there are these all-powerful gods or God who knows everything about you and has a plan for the universe. Hunter-gatherer religions almost never have that quality. Rather, they tend to be about ancestors, and they tend to be about ghosts and spirits, and they involve things about life and death, but they often involve all the bad luck that happens to you. And so you and I are sitting around and lightning hits your hut and kills you. Or your hut, the roof breaks and kills you, but I had just left. Well, there's a million of those random chances in life, but why did it kill you and why had I got out first? And it makes sense when human beings have evolved to look for causes of events that we then start seeing those causes in ancestral and spiritual ways. And we think, oh, you had angered the ancestors, and the way they taught you a lesson was collapsing
Yeah.
your roof out on them. But I had done the right thing for them, and so they caused me to leave. I didn't know why,
Yeah.
but I just left before that bad thing happened.
Do you think that in the same way that sort of knowledge accumulated, that religious traditions and practices and ideas accumulated in some way? Like, is there a similar dynamic going on there?
Probably. I mean, we know that in small scale societies, that is, the sort of non-industrial societies, hunter-gatherer type societies, they all have different forms of religion, and they often don't know much of the details. So if you ask them, why did that happen? They'll say, well, the spirits did it or the ancestors did it. But if you start to ask the kind of questions that I could ask you about Christianity, well, what happened then, and why did they make this decision, and who did that next? You could tell me enormous amounts of knowledge. They can't necessarily tell you that. They all believe stuff, but without knowing a lot of the detail, because it's not really written down. It doesn't get formalized. There's not a formal church where people have a job of generating this knowledge and passing it along and accumulating it by writing it down and things like that. So they'll have people whose job is to be involved in religion, but they don't necessarily ever tell you what they know and what their experiences are. They just guide your behavior.
Right.
So you might hire me to come in because of your hut fell in on your auntie and you want to know why, and I'll come in and explain to you what happened, but I won't tell you the underlying rules that allowed me to infer that. I might just have this direct communication with the ancestors, or often they take drugs, and then of course those drugs allow them in their minds to have these communications with their ancestors, and they'll tell you what they learned in that experience, but there's no body of religious knowledge like we have in hunter-gatherer societies. You now have in Hinduism and Judeo-Christian religions and Buddhism, all these big hunter-gatherer, religions that are post-agriculture have these bodies of knowledge with them that hunter-gatherer religions don't have.
Interesting. So do you think that like the transition from those sort of smaller, more humble religious ideas, smaller is maybe not the right way to describe them, but the types of religious ideas that you just mentioned, the journey from that to seeing these sort of like big institutionalized iconic religious practices and traditions, do you think the journey from hunter-gatherer societies to agrarian societies has something to do with that?
I do. I mean, what all the data seem to suggest, there's a lot of argument about the details. This is a very active area of research, right?
Yeah.
And so people want to know, what they call them in the literature, it may sound offensive, but they call them big gods.
Sure.
And what they
that
mean
makes
is
sense.
all powerful. Yeah. And so they ask the question, did big gods precede industrialized societies, or did big gods follow industrialized societies? And there's people on both camps. People argue about this a lot. But one thing that basically there's agreement on is that societies that have these religious traditions where with all powerful gods, they tend to cooperate better with each other across very broad boundaries. Remember that we originally evolved to cooperate only within our small bands, because another small band of humans may be a threat to me. They may decide that they want to trade with me, and it might be a plus, but they may decide to kill me and take the stuff that I own. And so we've evolved very strong tendency to be cooperative within our group, but not cooperative between groups. Now, religion solves that problem by getting us all of us who are adherents to the same religion, we see each other as brothers and sisters. We're going to cooperate with each other within those boundaries, and we all share a set of rules about how life is meant to be lived.
Yeah.
Whereas if you look at the morality of small hunter-gatherer groups, they might be quite different and in disagreement. So when you get big societies in these cities and post-industrial worlds, religion helps people cooperate. It helps people integrate with each other. It has all these societal benefits. And so the argument is that it's not an evolutionary process, but it's a cultural process, that the cultures who did it became more successful than the cultures who didn't, and so they replaced them.
Wow, yeah, that's really interesting. I can't remember. Again, I read Sapiens and your book back to back, so I get the two.
It gets blended together.
I get a little mixed up because it was also a couple of years ago. But I remember, I think I've heard you mention somewhere that this number isn't really exactly necessarily all that meaningful, but I heard somewhere in the vicinity of like up until about 150 people or so, we can have personal individual relationships and like, oh, I know Bill, I trust him, that kind of thing. But then beyond that, we need something else to adhere a larger group, and religion may have played that role.
Right. I think so. And the 150, the data seem to suggest that it's probably not that
Smaller.
important.
Oh, okay.
Yeah. In most hunter-gatherer groups, they're not. They're smaller than that. But also it's the case that some people have lots and lots of friends and they can know each other and their relations, and some people are more introverted and they're not as into that. So I think that 150 may prove to be a useful number, but may not. But more importantly, if I'm a Hadza, and so I'm a hunter-gatherer. As soon as I encounter you, I can tell by the way you dress and your accent if you're also a Hadza, even though I never met you. And so I can go, hold on, how could it be that you're a fellow Hadza and I don't know you? And I'll say, well, I'm so-and-so's son and so-and-so's nephew. And you go, oh, I'm the cousin of, and then we find that connection, because otherwise it's a little bit nerve-wracking to encounter strangers. And so we tend to make sure that we know people who we know. But at the moment I see you, I know you're probably not a threat because you look like me, the way you dress, I mean. Also, of course, your ethnicity is going to be like mine.
Yep.
Because people, when they're walking, they never encounter people of wildly different colors, right?
Right.
That would have been, you'd encounter people who tend to look like you. But the better guide was probably accent and probably style of dress. And that communicated immediately to me that you're in group and so therefore not a threat. And now I just have to figure it out. Like, well, how come I don't know you? Oh, yes, we're both great auntie Goethe's, third cousins, whatever, right?
Yeah.
So it's, even if I don't know you, I've got good cues that tell me that you're a member of my group or you're not. And so, and then once I do know you, of course, you've joined my camp because Susie invited you in, and off we go, and we get to know each other and we see if we like each other or not. But yes, it's definitely the case that compared to the other primates, we're capable of remembering much larger groups of people and forming friendships with them. And not just friendships with them, but it's also mission critical for me to know how you feel about Susie. Because I want to be able to tell you, oh, I love Susie. And I don't want you to get all angry because you love her too. I want you to say, oh, that's great, because I love Mary. And Susie and Mary are good friends. Let's all go do whatever together, right?
Yeah, that's interesting. Yeah, that's super helpful. I don't want to take up too much more of your time, but your book takes an interesting direction toward the end, talking about happiness, which was sort of unexpected for me. And I know we could talk about happiness, just that idea, and sort of we could talk about that for a whole show. I'm going to link in the description to this episode a talk that you gave about happiness that I found, and I can't remember exactly what it was titled, but I watched it recently, so I'm gonna. You probably know the one I'm talking about.
I think it's the alumni one that I gave here at University of Queensland.
Yes,
but I've done a few of them.
Yeah, I'm gonna link that below. So just so you don't have to feel like you have to, outline it too much. But for people that are watching and listening, that'll be in the show notes and the YouTube description. It's super worth your time. It's really fascinating. And but maybe we could sort of close this conversation talking a little bit about happiness and how we can understand happiness through the perspective of sort of the evolution of our psychology.
Sure. So look, it links back to a point that you made earlier, and that is that the individual doesn't need to know why they do what they do. They just need to be motivated to do it. And so what that really tells you, if you reflect on that, is that evolution can exert its effect through emotions. It doesn't need to exert its effect through knowledge. So human beings don't need to understand the causal order of, I have sex, therefore I have kids. Kids are good because they pass on my genes, because I have genes, and I want that to happen. All they need to do is be motivated to have sex, that they enjoy it, right? So what evolution did is it made those ancestors of ours who did the things that were in their genes' best interests. That is, they helped their body survive, and then they partnered up with somebody, they reproduced, and then they helped their children live. They looked out for them and fed them and took care of them. Those individuals who wanted to do those things, who found that to be enjoyable, are the ones who passed on their genes more than those people who found it onerous. So somebody goes, oh, sex is gross, I don't want to do that. Well, none of them are our ancestors because they didn't do that, and therefore they didn't have kids, and therefore they didn't pass on that tendency not to like it. And so if you step back from that understanding, then you realize, well, happiness is a really critical emotion. It's what evolution gives us to reward us for when we do something that's in our genes' best interests. And so once you think about it that way, then you realize, well, what are in our genes' best interest ancestrally? What was in the long-term interest of our likelihood survive and to reproduce. And that was to have good friends, people I could count on. So, somebody that you meet and you like is nice, but if you never see them again, it's not that important to your fitness. Whereas somebody that you meet and you cooperate with and you work together with and you really get to know, they're super important. You can now count on them. And so when someone comes to beat my face in, or I need a hunting partner, I can turn to you, John, and say, hey man, we've been in the same group for a long time. We get along well. I need your help. And you go, I'm with you, Bill. And so good friends are super duper important, but perhaps most important is romantic or sexual relationships, and ideally long-term ones. Short-term ones have their advantage evolutionarily because they give you a chance, if you're male, to have a kid that you might not have otherwise. And if you're female, they give you a little bit of variability in the genetics of your offspring in case times change. Maybe it'd be good to have one of those in the family. But really, human beings they're so inept when they're born. They're so useless that they need so much care that it takes long-term relationships between two parents. And we see the exact same thing with most birds. Birds have to live up in a nest. They can't fly when they're born. And so parents have to bring it food for a long time. And that typically requires two parents. And that's why most birds are long-term pair bonding. They find a good relationship that they can count on. And then for the rest of their lives, they raise the same baby. They have eggs together. They raise the babies. They put in the hard yards. And presumably that makes them happy. We can't query them, but the point is, in humans, it will make you happy. Having good long-term relationships is one of the best recipes to happiness. And part of the reason for that is that if happiness is going to work, evolution has to give it to you, but then take it away again so that you're remotivated. And one of the very few things that it'll give you and then not completely take away is if it gives you a good relationship. If you have the good luck that you find a partner who's really compatible with you, then it's one of the few cases where we see that happiness rises and it stays higher pretty much forever.
Wow. That's really interesting. I mean, I've been married for 14 years, and I notice that our relationship has these waves. We have seasons where it's like where we feel a little bit like roommates, and now we're raising two kids together, and so it's like, oh, we like in a very practical way, like we really need each other, right? But it's not always romantic. And then we have these moments that sort of spontaneously out of nowhere are just like, oh, I really love you, and you're really special, or she'll do something that unexpected, and I'll be like, 15 years in, I didn't know this about you. It'll sort of re-spark something, and I notice that there's this up and down thing, and I mean, does that?
And that's a really good example of how we evolved these long-term pair bonds in order to help us raise children. And so you're right now in what I would say you're in the trenches.
Oh,
You've
got
a 2-year-old and a 4-year-old, and it's hard yards, right? It takes an enormous amount of effort. And so naturally, you're going to be focusing your energies on them. And the two of you are working together kind of, as you say, like roommates or teammates or whatever, swap out. It's a little bit like tag team wrestling.
Yeah.
Now she touches your hand and now you're the one changing the nappies or, whatever, right? As you guys try to keep the family afloat and try to keep the family unit going. And then kids get older and then the relationship takes on a new quality because now they think you're both idiots and you guys can kind of, you have to team up and try to help survive that phase. And so, but then there's also, as you say, along with it, this romantic phase that always is underlying it because, of course, evolution wanted you to have more and more kids. Now, we intercept that in the current world because we have modern contraception. But if we didn't, you would be having lots more kids because every time you guys felt amorous again, the chances are good that you'd have another child. And that's what's actually in your genes' long-term best interest is to produce as many high-quality versions of yourself as it can.
That does make sense. And I have circumvented that process very recently, very permanently. Well, semi-permanently anyway.
But it wasn't available to our ancestors, not without a bad accident.
Right. So that's interesting. So happiness is something that it's almost like a carrot that gets dangled in front of us.
Yeah,
it's
exactly.
like I imagine like the ant in Honey, I Shrunk the Kids, right? Like they hung the piece of the cookie in front to get the. So it's like something that helps us move forward.
Happiness is that dangling carrot to get you to go where your genes want you to go, to give them the best chance of duplicating themselves and creating an environment that'll be successful for the next generation.
Has your research shown, or your learning on this subject, has it shown any indication of like how we can maybe orient our lives differently, having the knowledge that that's how that works? Like, are there any, like, does it change or can it change the way we live and behave in any meaningful or helpful ways?
That's a great question. I haven't looked into that. My guess is that it helps you understand that we all have our baseline levels of happiness, and if you're lucky, that's pretty happy. But it helps you understand why, when you get really happy, that can't last. Even if you win the lottery, even if you get that big promotion, even if you get to buy the new Ferrari, you're going to go right back to your baseline later. And so it's useful to know that, because what you really ought to be pursuing is not these kind of monetary or status rewards, but rather the relationship ones, because they're the only thing. And it makes sense evolutionary. They can bring you higher and keep you there.
Oh, that's such a good point. So the moral of the story of humanity is put people first.
Yeah, long-term cooperative relationships make us happy.
I love it. All right, that was fantastic. Thank you so much for. I mean, you just told the story of humanity in 90 minutes. So, thank you so much for
totally my pleasure
for spending this time with me. I recommend your book constantly. It's in the
Good.
It's no, I mean it. Like actually, just totally honestly, like reaching out to you, I was like, I don't know. Can I get a conversation with him? So like, there's, for my journey, for my process of learning, like the last 2 or 3 years, I've been studying a ton of different subjects as I've come out of these religious spaces into a more secular sort of worldview. And now I make things for people going through that same journey.
Yeah, I think that's great. And I was very intrigued to talk to you once you contacted me, because I've not had this conversation before. And I didn't know that you were doing this. And so for me, it's been great fun chatting with you about it.
Yeah, thank you. Well, I mean, one of the reasons that I recommend your books so highly is because of the way that you approach these things. You're not coming at these things from a tearing anything down point of view. And I'm not, I'm trying not to do that either, but to understand who we are and where we come from, and how that actually can be really helpful information to know.
Absolutely.
And to sort of guide our lives. And so, the Social Leap, for any of you guys watching, listening, I just cannot recommend this book enough. Please go check it out. And and Bill, any other ways that people can learn more about you or support what you do?
Well, I always love hearing from people who have ideas that they bounce off when they read it, and lots of people get in touch with me, and we've got these various podcasts up, and we've got a lot of the original articles as well, and of course, there's lots of other great books too. I mean, there's a ton out there for people who want to start this exploration, and there's even a website now that I can't remember the name of it, but where they contact authors and ask them to recommend books. And if you Google me, I bet you'd find my recommendation in there. So if you want to see, there's lots of other books that look at a lot of the details of what we've been talking about that can allow you to start educating yourself in these domains. Because of course, I'm just a psychologist. I had to go through this process too, right? I spent the last 20 years trying to learn anthropology and biology, a bit of economics, archaeology, in order to try to understand this bigger picture in which we live.
Yeah, well, and that's a really good point. Again, to come back to your book, one of the things that I appreciated about it is it was very easy for me to understand, as someone who didn't have a background. Sometimes when I get real deep in a subject, I find myself like having a hard time, like reading Hume or Heidegger or something like that.
Yeah,
I'm just
same.
like,
I'm like, what is he trying to say?
Right. So yeah, that's awesome. Well, thank you, Dr. Von Hippel. I really, really appreciate you spending this time with me. And I can't wait for everyone to hear this conversation.
Totally my pleasure. It was great chatting with you, John.
Okay, that was my conversation with Dr. William Von Hippel. Thank you guys so much for joining me if you've made it this far. If you happen to be listening to this or watching this as soon as it comes out, it's Sunday night. As I'm speaking, it's Sunday night, the 29th of September. Nope. It's Sunday night, the 29th of August, 2021. If you happen to be catching this right away, in just a few days, I'm going to be doing our first live stream on this show with a philosopher that has a theory of consciousness that's very interesting. His name is Dr. Philip Goff, and I'm so excited to have this conversation about consciousness. And he defends a theory of consciousness known as panpsychism, which is the idea that everything is conscious. So I'm really, really excited to have that conversation with him and share it with you all. It is going to be this upcoming Wednesday. It is going to be this upcoming Wednesday at just after 12 noon Pacific time, which is my time. So that's about 3 p.m. Eastern, and that's 8 p.m. in the UK where he's located. So please tune in for that, and come and bring questions, because we're going to start taking questions live on air. And I'm so stoked about doing this stuff live. So thank you guys so much for listening, for watching. I hope to see you on Wednesday. Take care. Until next time, stay curious.